I'm gonna try again. Guys, are you kind of sweaty right now?
Yeah!
Sweat. That lovely thing you're covered in after physical activity. Many of us would think it was just water. However, sweat is full of much more than just that. To function properly, the body needs to maintain equilibrium for all the substances in it. One of these substances is salt, specifically sodium. In our Group 4 project, we decided to investigate how prolonged physical activity, running, changes the salt content measured in the sweat. First, we went to the print room to grab our sheets, and then went to a briefing with Adjutant Rob, who would be telling us about what we were doing.
To measure the quantity of sodium in sweat, we have to sweat.
After consulting with some of the adjuncts and collecting the material we would need to conduct the experiment, we followed Pat's instructions and went to sweat. So right now we're heading to the track where we're going to begin conducting our experiment. We have got the test tubes, the tripod, the computer, the data logger. We have got our mobile lab set up and ready to go. Are you pumped, guys?
Actually, it's not set up yet. We still have to set it up.
We are ready to set it up and be ready to go momentarily. Ow.
Ben,
Yes.
how do we collect your sweat?
Sorry?
How do we collect your sweat?
Swab. So we set up our mobile laboratory and prepared the test tubes. After running for a certain amount of time, we would gather the sweat via swabs of the participants to measure the saline concentration later on. Wonderful. How are you feeling?
Tired?
These experiments can really take a lot out of you. Some more than others. After many hours, our experiment was completed. It was during this time that we conducted our last tests and made sure that we had all the results measured. To do this, we used the salinity probe, placed it in the test tube, and checked the conductivity level. We could then process the results. However, not before lunch. How's food? After lunch, we headed back to the science lab where we could process our results. Christian has more on the details.
Our project revolved around the amount of salt in sweat and the amount of exercise that exerted these levels of salt. We were unable to measure the amount of salt in the sweat directly, but we know that there is a positive correlation between conductivity and salt content. Thusly, we were able to measure conductivity to identify patterns that we were then able to interpret using our graph. In the graph, we can clearly see that Pat's data was above the rest of the trials, but normalized near the end. This could be due to our process not being specific enough for our test subjects, and each person is doing the test in their own way. The difference in measurement in gathering of the sweat, per se, could be enough to cause a level of difference between Pat and Alice and Ben that would not be seen otherwise. In the graph, we can clearly see that Pat's data was above the rest in the later trials, but normalized near the end. This could be due to our process not being as specific enough for the test subjects and them doing the gathering of the sweat themselves. If Pat had used a different method of gathering than Ben and Alice, would obviously cause an outlier. Now, both Ben and Alice's data were similar most of the time, but they varied at the very start in the data for the 2-minute run. Our data ended up being inconclusive for the question that we aimed at due to Pat's outlier, but for the most part it seemed pretty consistent, therefore that would prove our hypothesis correct, but to clearly have an answer to that question that was asked, we would need to re-perform this test with modified process to become what is an equation.